Good morning. Our topic for this morning is all about non-renewable energy. We will discuss energy, fossil fuels, coal, oil, natural gas, fossil fuels, and greenhouse gases, and nuclear energy in this chapter. And our learning objectives, by the end of this chapter, students will be able to list specific examples of non-renewable energy sources, explain what makes an energy sources non-renewable, describe the main types of fossil fuels and how they are formed, explain the environmental impacts associated with exploration, extraction, and use of the different types of fossil fuels. And you will be able to explain nuclear energy, how it works, its benefits, and its risks. So let's talk about energy. Where do we use energy? Okay, we use energy in our transportation. We use energy in cooking, like fire. We use heat and light energy for that, and also electrical energy for powering up our appliances. Here is the definition of energy. Energy is the ability of a system to do work. A system has done work if has exerted a force on another system over some distance. So if you push a chair and it covers a distance, so you are applying work and you are also consuming energy when you apply work. And also energy is transferred from one system to another. At least some of the energy is also transformed from one type to another during its process. For example, we have here a dynamite. From a chemical potential energy, when you light up a dynamite, it converts chemical potential energy into light energy and heat energy. So take note that we have the law of conservation of mass and energy, where it states that energy cannot be created nor destroyed, but only be transferred from one form to another. Here we have two types of energy, kinetic energy and potential energy. If you have noticed, the energy possessed by a moving object is called kinetic energy, while the energy possessed by a static object or not moving object is called potential energy. Here are the definitions for the two. Kinetic energy refers to the types of energy associated with motion, while potential energy is the energy possessed by an object or a system due to its position. Take note that living organisms need energy to perform life-sustaining work in order to survive. For nearly all living things systems on Earth, the sun is the ultimate source of that energy. Over time, we humans have developed an understanding of energy that has allowed us to harness it for uses well beyond basic survival. The development and evolution of human society is largely attributed to our relationship with energy. Now let's move on to fossil fuels. When we say fossil fuels, it is the term given to energy sources with a high hydrocarbon content. So like dead animals or decaying plants or trees, those objects have high hydrocarbon, thus they turn into fossil fuels. We have fossil fuel types, oil, natural gas, and oil or coal, rather. Let's start with cap rock. When we say cap rock, it is a relative impermeable rock that forms a barrier or seal above and around the reservoir rock so that fluids cannot migrate beyond the reservoir. Because fossil fuels are liquids, they tend to go out of any holes because they are fluids. Therefore, the cap rock is an impermeable rock that seals the reservoir, or it is the reason why the fossil fuel stays on the ground because of the cap rock above the reservoir. Here is the diagram of the formation of fossil fuel. At first, 300 to 400 million years ago, there are animals, ancient animals living on Earth. And after some years, those animals die because of natural reasons or calamities. They tend to remain on the sea floor. And then over millions of years, sand and silt or other soil overburden the plant and animal remains, thus turning it into oil and gas deposits through time. So the formation of fossil fuels takes 50 to 100 million years. Here is the distribution of resources around the world. So the use of petroleum is about 36%, natural gas is about 29%, coal is about 16%, and renewable energy is only 10%. And we have nuclear electric power that comes from nuclear power plants. That's only 9% because um, developed countries are the ones who are using nuclear electric power. Now let's move on to coal, the first type of fossil fuel. A coal is a fossil fuel that formed from the remains of trees, ferns, and other plants that lived 300 to 400 million years ago. So coal initially came from dead plants. So that's 300 million years ago. So dead plants become overburdened by dirt and other soil and turns into coal after 100 million years due to heat and pressure. So the factor for making coal or the factors for turning dead plants into coal are heat and pressure. So take note of that. So as we all know, using coal have a disadvantage. So it releases sulfur dioxide. So in some areas, such as portions of what is now the eastern United States, coal was formed from swamps covered by seawater. So the seawater contained a large amount of sulfur, and as the seas dried up, the sulfur was left behind in the coal. Scientists are working on ways to take the sulfur out of coal because when coal burns, the sulfur is released into the atmosphere as an air pollutant. Some coal deposits, however, were formed from freshwater swamps which had very little sulfur in them. So these coal deposits located largely in the western part of the United States have much less sulfur in them. So the coal found in swamps or from swamps that are covered by seawater have higher sulfur content than those from the freshwater deposits. So fossil fuels can be utilized without being converted or transformed to another form of energy. So we call that primary energy consumption. When the fossil fuel is directly used as a form of energy, so that is primary energy consumption. While when you convert it into electricity and use it as an energy, so we call that secondary energy consumption because you converted fossil fuel already to other sources of energy. So transforming fossil fuel energy into electricity allows for easier transportation over long distances and application to a variety of uses. Now let's proceed to coal mining and processing and electricity generation. There are two primary methods of coal mining. We call that strip mining and underground mining. When we say strip or surface mining, it uses large machines to remove the soil and layers of rock known as the overburden to exposed coal seams. It is typically used when the coal is less than 200 feet underground. So it is only applicable when you are digging the deposit in less than 200 feet underground. We also have mountain top removal. It is a form of surface mining where the top of mountains are blasted with dynamite and removed to access coal seams. Okay. After the mining is finished, the disturbed area can be recovered with topsoil and the area is replanted. However, the topography of the mountain is permanently altered. So we have a law for that. So mining companies should replant or recover the topsoil with vegetation. And for your group presentation, prepare for these topics: coal power plant, natural gas power plant, and nuclear power plant. You have to research for the advantages, disadvantages, extraction uses, and countries that have this kind of power plant. So that's the end of our first topic. Thank you for listening and